And here is number 9. Again, this is similar to your assignment, though a little bit different numbers. X to the 12th divided by x to the a equals x to the 3rd, and x to the 8th, quantity raised to the b, equals x to the 16th. We need to find a and b so we can determine what a minus b is equal to. All right, Owen's going to lead us through this. First, we are going to look at x to the 12th divided by x to the a. Remember, when you are dividing, you subtract your exponents.
Divided by a minus.
Yep, minus a.
Minus a.
That's a minus a. Okay, is equal to x to the 3rd power. Okay, now since we have like bases, we can assume those two exponents are equal to one another. If you have the same base to different exponents and they're equal, they must be equal to each other. So Owen is going to take us through the process of solving for a. Our equation is essentially 12 minus a equals 3.
And then we can reverse it to 12 minus 3 equals a. That equals 9. So that means a equals 9.
Very good, Owen. I'm not used to seeing it written that way. I like it. All right, next is x to the 8th power to the b power equals x to the 16. When we take a power to a power, we multiply the powers together. So we have x to the 8 times b. And that still equals x to the 16th. Very good. Now again, we have like bases, however, not like terms. We have like bases. They are taken to different exponents, but equal to each other. So we know 16 is equal to 8b. Okay, so 16 divided by 8 is equal to b. And what does that give us?
That gives us a good old 2.
All right, so b is equal to 2. And what would it be? What's the value if we said a minus b?
A minus b, that means 9 minus 2 gives a good old 7.
It's a good old 7 is the answer to this one. Number 10. I'm going to take this one over because Owen is in the other room right now. Owen! All right, Owen, you're taking it over. All right, so we have x equals 3 to the 3a plus 2, y equals 9. We want to find x divided by y. So we are going to substitute in what we know for x and y. 3 to the a plus 2 divided by 9. Now, in order to do this division, we want to look for like bases. So Owen is going to change the 9 to a base of 3. And we do that by writing 3 squared. Good job. All right, next step, we can go ahead and write one base of 3. And then remember, when you're dividing, your bases subtract. Okay, so we have 3 to the 3a plus 2 minus 2. And now we can simplify that to the 3 to the 3a. Okay, 3 to the 3a. The 2 minus 2 at the end canceled each other out. So we are all set here. Thank you, Owen.
Hey, this is something I'm going to do on my own. Okay, so we're trying to figure out what a plus b equals. And there's 4 possible answers for this. So a could be, positive 4. And then B could be a negative or positive 6. Okay, so here are all of the possible combinations for A and B equal question mark. Okay, so A is a positive 4, positive 4, sorry, not 4, that's an H. Negative 4, negative 4. And then we do negative 6, positive 6, negative 6, positive 6 could equal what? Okay, so it could equal, for the first row, it's positive 4 plus negative 6, which equals a big old negative 2. Positive 4 plus positive 6 equals a positive 10. A negative 4 plus negative 6 equals a negative 10. Or negative 4 plus a positive 6 equals a positive 2.
Number 13. So this is the fourth time I'm doing number 13. The first time I approached it the wrong way. The second time I ran out of space on the board. The third time my camera ran out of space to save videos. Yeah. Okay, so we have the problem. The square root of AB equals the square root of BC. The square root of AC equals the square root of 16c to the 4th. Then they tell us A, B, and C are all greater than 0, and they want us to find C. So I stared at this for probably longer than I should have the first time. So the first thing that I want to do is I'm going to get rid of all these square roots. Nobody needs them, right? So the square root of AB is equal to the square root of BC. I can square both sides of the equation. Because remember, if you do something to one side of the equation, as long as you do the same thing to the other side of the equation, you keep it balanced, you keep it equal. So when I do that, the opposite of a square root is a square. We've talked about that in class. And so now I just have AB equals BC. Okay? Now, this name of the game here is to find C. So I'm going to solve this equation for C by dividing by B on both sides. Lucky for us, there was already a B over here, so I was able to cancel B out on both sides. We get C is equal to A, or A is equal to C. That's not our final answer, but it does put us in the right direction, okay? I'm going to do the same thing with my radicals over here on the other side. I don't want to deal with square roots if I don't have to, so I'm not going to. Okay, let's square both sides. I get AC is equal to 16c to the 4th. Now, there's a few different ways we can approach this from here. And any way you do it, as long as you get the right answer, you follow the rules of math, is fine by me. But I'm going to show you my way. So we have an equation with AC and C. We want to know what is C. So I'm going to get rid of that A. I don't need it. I don't want it. And I know A equals C. Okay? So if A is equal to C, I am going to use substitution. Instead of A, I'm going to write C. So we have C times C equals 16c to the 4th. C times C, you add your exponents if you're multiplying. Assume they both have a 1 okay, if they don't have any at all. So that's c to the 1 plus 1 or c squared. Okay? Again, a couple ways you could approach this from an algebraic standpoint. What I'm going to do is I am going to divide both sides by c squared just to get rid of c squared over here. Now all my c's will be moved over to the right side. That's why I'm doing it. 1, not 0. C squared divided by c squared is just 1. Anything divided by itself is just 1. Over here, 16, c to the 4th divided by c squared. They have the same base. They're both c's. So we can do that. We just have to subtract the exponents. 4 minus 2 is 2. Now, what we could do is divide both sides by 16. Again, the first step in an algebraic equation, you want to get all the variables on one side. We did that. Now I want to get that variable by itself. So the first thing I'm going to do is divide both sides by 16. That'll cancel. So I have 1 over 16. Bear with me here. I'm going to go to this side so I don't run out of room again. 1 over 16 equals c squared. Now remembering back to algebra, we can take the square root of both sides. I want c squared by itself. I want c by itself. So to get rid of the square, we take the square root. Kind of the opposite process we used up top. What you do to one side, you have to do to the other side. Now remember, if we're dealing with a square term, this is going to be plus or minus the square root of 1 over 16. If you forget that, on this problem, it's actually okay. It'll work out for you. But if you're taking the Algebra EOC, ACT, SAT, CLT, PERT, then you want to make sure that you're putting that plus or minus so you don't mess yourself up. Okay? So here we have plus or minus. The square root of 1 is 1. Square root of 16 is 4. Our square and square root cancel. Our answer then is plus or minus 1/4. Now I'm looking at the answer choices and everything's positive and there's a reason. Why? In the beginning they said A, B, and C are greater than 0. Okay, we don't want to work with negatives underneath the radical signs. And in telling us it's greater than 0, they're telling us, hey, ignore that negative. Your correct answer is going to be 1/4. Okay? Problem solved. Again, this is not the same problem that's in your homework. So, I know it's a little long, a little confusing. Do it on your own. See what you can get. Rewind this video, pause it, do what you got to do. Your answer is not 1/4, and if you mark 1/4, it is definitely wrong. Thank you. Number 14, x to the 27th over x to the 9th divided by x to the 4th divided by x to the 16th. I do not want to be on camera because I spent all day taking care of a sick child, but he's doing much, much better. All right, we are going to take this one step at a time. First, all right, my equal there. X to the 27th divided by x to the 9th. If we have like bases, we subtract our exponents. That gives us 27 minus 9 is 18. On bottom, if we divide, we subtract our exponents. 4 minus 16, negative 12. Do not freak out that you got a negative in the numerator. That is fine. Remember, we have a rule about that. If you have a negative in the denominator, that means it can move, it can flip up to the numerator and become a positive exponent. Okay? So now we have x to the 18th times x to the 12th. When we multiply like bases, we add the exponents. We get x to the 30th. Remember, this is an example problem. Your problem in the assignment has different numbers in it. It's the same process, but different numbers, different answer. Number 15. In this set of real numbers, what is the solution of the equation 4 to the 2x plus 3 equals 8 to the 1 minus x? So first thing we're going to do is look at 4 and 8. Can they be changed to have the same base? I notice 4 is a perfect square. I notice 8 is a perfect cube. If you don't recognize those, then we need to work on that. Okay? So 4 can be written as 2 squared. We still have 2x plus 3 in that exponent. So 2 squared takes the place of 4. 2x plus 3 gets multiplied by that square that we just put up. 8 is a perfect cube, and our exponent still has 1 minus x. It'll be multiplied by the cube. So 2 to the third is the same thing as 8. And then we multiply our new exponent by the old exponent that was already there. So now we have 2 distribute 4x plus 6 equals 2 distribute 3 minus 3x. Well, if they have the same base, okay, they both have a 2 as the base, then we can assume that those exponents are equal to one another, because 2 to a power is equal to the same power. So 4x plus 6 equals 3 minus 3x. We all love our algebra. I want to get x's on one side, constants on the other, so I'm going to add 3x to both sides. And I'm going to subtract 6 from both sides. You might want to do that one step at a time. I understand. Essentially, our 6's cancel. We are left with 7 x's over on the left. Our 3x's cancel. So we are left with negative 3 on the right-hand side. So in the interest of space, I'm going to move over to this next area here. I have 7x equals negative 3. That's what we get when we get x's on one side, constants on the other. Now I want to divide both sides by 7 to get x by itself. And I get negative 3 over 7 as my answer. That is a real number. Negative numbers are real numbers. So x equals negative 3/7. Remember, this problem is not identical to yours. Make sure you're checking your numbers and working through the process. Number 16 is a difficult one. It involves some critical thinking on your part. I don't want to be on camera because I took care of a sick child all day, so I'm going to use my Mickey pointer thingy. Actually, it's Owen's. All right, so let's think about some of these things. If we have a positive exponent, x to the positive 2, the answer is always going to be positive, and in the numerator, not positive. Retake. Number 16 is a difficult one. It involves a lot of critical thinking. I am not going to do it for you. I want to see your thought process, but I will give you some notes here to help. If we have a positive in our exponent, and I'm using the Mickey finger because I don't want to be on camera, our answer stays up in the numerator. If we have a negative in our exponent, we flip. And the reason I have the x is because on number 16, you don't have to deal with a negative exponent. So that was cool of them at least. Even exponents. If you're taking something to an even, your answer is always positive. Even if you're taking a negative to a even exponent, you get a positive number. If you take a base to an odd exponent, you get whatever it originally was. So in the case of a positive x, you get a positive x. In the case of a negative x, you still get a negative x. And I gotta reach in my real arm because it has to be cubed. Okay? Now I want you to think too on number 16 about what is a prime number. Okay? The lowest prime number is 2, and they tell you it has to be greater than 2. Okay? So when they talk about that prime number, it can't be 2. Think about the next prime numbers. Remember, a prime is something that can only be divided by itself and 1 evenly. Dot, dot, dot. If you notice, those are all odd numbers. So if you have a prime greater than 2, it has to be odd. Otherwise, anything even would be divisible by 2 evenly, so it can't be prime. So that's a big hint for you. The odd, notice we just talked about odd numbers. And then remember these other facts, and hopefully you can do number 16. Show me your work, show me your process. Do not show me an answer. Do not show me an answer from AI, because I will know that it wasn't you. So I want to see your work. Okay. Thank you and good night.
Hello.